In this video, we will talk about solving logarithmic equations. There are two types of equations. This video will stress or focus on the first type of equations where you have a log on one side and a number on the other. The second video will focus on the other type of logarithmic equations where you have log on both sides of the equation. So let's go ahead and start with our first example. Now, you see how you have log on one side of the equation and a number on the other? So the first step to do something like this is to isolate the log. So let's highlight the first step. The log is isolated. There's log of 27. There's nothing being added or subtracted, nothing being multiplied, so the log is isolated. My next step is to change to exponential form. So when I would do that, I would start with the base, and I would raise this base to the power 3 over 2, and that's going to be equal to 27. So x to the power 3 over 2 is equal to 27. Now, how can I solve for x? To solve for x, you get rid of the power by multiplying it by the reciprocal. And whatever you do to one side, you do to the other. Now, 27 means 27 to the power 1. So I need to multiply the 1 by 2/3. So to get rid of a power, you see how 3 and 3 will cancel out and 2 will cancel out. So you are left with x to the power 1 equals 27 to the power 2/3. Now, I don't know if this yellow is clear, so let me change to another color. So this is how you change to exponential form. Let's review how we do that. We start with the base to the power 3 over 2, and that's equal to 27. Now, to get x by itself, to get rid of this power, I multiply it by the reciprocal. Whatever I do to one side of the equation, I have to do to the other. Now I need to solve for x. X equals 27 to the power 2/3. Now, 27 can be written as a 3 to the power 3, because 3 to the power 3 is a 27. And let's keep the 2/3 on the outside. So you see what I'm trying to do? I'm trying to get 27 to be a prime number to a certain power, because a power to a power, what do? You multiply. So 3 and 3, 3 times 2/3, 3 and 3 will cancel each other. You are left with x equals 3 to the power 2, which is a 9. Now don't forget to plug that back in and check your answer. So let's see, 9 to the power 3 over 2, that is equal to 227. So always check your answer. Now let's move on to our second example. Again, the log is isolated. Now, a common mistake that students do is that they add 9 to both sides of the equation, thinking that this is how you isolate the log. But x minus 9 are together inside the parentheses, so they are the argument for log. So the argument for this log is x minus 9. So the log is isolated. There's nothing being added or subtracted on the outside of the parentheses, so the log is isolated. Now the second step is to change it to exponential form. To do that, you start with the base to the power 4, and that is equal to x minus 9. So 2 to the power 4 is equal to x minus 9. Now 2 to the power 4 means 2 times 2 times 2 times 2, which is 16, equals x minus 9. Now don't forget to add 9 to both sides. 16 plus 9 is a 25, and this is how much x is. Now remember, always check your answer and see if it makes sense. So 25 minus 9 is 16. Log base 2 of 16 is equal to 4, so we are good. Now let's move on to in our third problem, we see that the log is not by itself. We have to isolate it. We start by subtracting 15 from both sides. So we get 2 log base 2 of x equals 25 minus 15 is a 10. Then I see that there is a 2 multiplied by the log, so I divide both sides by 2. So log base 2 of x is equal 10 over 2, which is a 5. Now there you go, the log is by itself. Now to solve for x, I have to change to exponential, so 2 to the power 5 is equal to x. 2 to the power 5 is a 32, so x is equal to 32. Now don't forget to check your answer. Now let's move on to example number 4. Now, some of you might look at this and say, okay, I have logs on both sides, like I have two logs over here and I have a number over here. So is this log and a number situation? Let's see, can I combine these two to only one log? Yes, if I use something called the product property. So what does the product property tells you? It tells you if there's addition between the two logs, what you can do is you can condense them into one log and you can multiply the arguments. So x times x plus 9, and that is equal to 1. So there you go. It is a log and a number situation. I condensed these two logs using the product property to one log. Now, I need to change it to exponential form to be able to solve this. So I look at the base. Since there's no base, then the base is 10. So 10 to the power 1, that is equal to x times x plus 9. So let's write that down. 10 to the power 1 equals x times x plus 9. Now to solve this, we have to distribute the x. So 10 is equal x squared plus 9x. So I had to distribute that. Now since I have an x squared and an x, to solve something like this, I have to move everything to one side of the equation and set it equal to 0. Now, remember, always keep the x squared positive. So I'm moving 10 to the other side by subtracting it. So I get 0 equals x squared plus 9x minus 10. Now I have to factor this to be able to find the solution. Now since a is 1, then this is a mental math problem. You have to think of two numbers that multiply to give me negative 10 and add to give me 9. Now those two numbers are 10 and negative 1. 10 times negative 1 is negative 10. And 10 plus negative 1 is 9. So x plus 10 is going to be my first factor, and x minus 1 is going to be my second factor. Now to solve this, you set each factor equal to 0 and you solve for x. So the first solution is x equals negative 10, and the second solution is x equals 1. Now remember to always check your answers. Let's check negative 10. So we need to plug negative 10 for x. So log of negative 10, does that make sense? Remember what we said is that inside the log, I have to have a non-negative and a non-zero answer. Okay? So log of negative 10 does not make sense because there's no way with a base of 10, so 10 to the power, what would give me negative 10? That is impossible. Think about it. If you have a negative 10 on the inside of the log, 10 to the power, what would give me negative 10? No matter what the power is, even if it's a 0, 10 to the power 0 is 1, not negative 10. What if the power is negative? 10 to the power negative 1 means you have to flip the fraction, so that's 1 over 10, which is 0.1. Still not negative. So there's no way I can think of a power where if the base is 10 to the power what would give me a negative answer. That is impossible. So x equals negative 10 is an extraneous solution. And then my only answer then is x equals 1, but still I have to plug it in and check. So let's see, log of 1 is 0, makes sense. Log of 1 plus 9 is 10. So the base is 10, so 10 to the power what would give me 10? That's an answer of 1, so 1 equals 1, and that is correct. So that is my only solution. X equals 1 and x equals negative 10 is an extraneous solution. Now we're going to skip problems 5 through 8, because this is the second type of equation, and we're going to move to 9, 10, and 11. So let me free some space over here. Okay. Now let's move on to number 9. Now you see how some of you might get a little bit confused and say, oh, I have a log on one side, I have a log on the other side, so this is a log-log situation. But do you see how there's a number? There's a negative 1 over here. That means that this is a log number situation because the negative is not part of the log. It's not inside the parentheses. So what do I do in this case? What I try to do is to move the 1 to the other side, and to move the log base 4 of x to the other side by subtracting it. So let's subtract negative log base 4 of x. So I get then log base 4 of 8 minus log base 4 of x. and that is equal to 1. So you see how I moved all the logs to one side and the number to the other? Now if I take a closer look at this, I see that this is a quotient property. And it tells me if you are subtracting two logs, then you can condense them into log base 4 of 8 over x. So what you do is you divide the arguments, and that is equal to 1. Now to solve this, as you can see, it's a log number situation and the log is isolated, so you change it to exponential. 4 to the power 1 is equal to 8 over x. Let's write this down. 4 to the power 1 is a 4 equals 8 over x. Now to solve for x, you can cross multiply, so 4x equals 8. Now to solve for x, you divide both sides by 4, so x is equal to 2. Now remember, check this answer, and you will see that it will make sense. This is how you would solve a problem like that. Now let's move on to number 10. Again, I have a number by itself. So this is a log number situation. So what I need to do is I need to move the negative 2 to the other side, and I need to add log base 8 of x to both sides. So if you add these two, you'll see that this is a product property. It means I have to multiply the arguments since we're adding. So log base 8 of 4 times x, and that is equal to 2. Now the log is isolated, so what you do is you change it to exponential. So 8 to the power 2 is equal to 4x. 8 to the power 2 is a 64. Now to solve for x, you divide both sides by 4, and x is equal to 16. That's how you solve a problem like this. Now, let's move on to number 11. Again, it's a log where I can condense these two is equal to a number, so that's a log number situation. So to combine them, I need to multiply the arguments, and that's equal to 2. Now, as you can see, the log is isolated. This is the argument of this log. Since I do not have a base, I know that the base, I can't see it, but the base is 10. So 10 to the power 2 is equal to this. So 10 to the power 2 is 100, equal to 2x times x minus 5. So let's FOIL or distribute the 2x. So I get 2x squared minus 10x. Now, since we have x squared and x, I have to move everything to one side of the equation and set it equal to 0. So 0, remember, always keep the x squared positive. Now, if we take a closer look at this, I can see that all of these are even numbers. So how about we divide everything by 2? I can do that because this is an equation. If it's just an expression, I can take 2 as a common factor, but this is an equation. So let's divide everything by 2 and get rid of the 2. So I get x squared minus 5x minus 50. Since a is 1, so this is a mental math problem. What are the two numbers where they multiply to give you negative 50 and add to give you negative 5? Negative 10 and 5. So x minus 10 and x plus 5. This gives me two solutions. You set each factor equal to 0, and you find the first solution to be 10 and the second solution to be negative 5. Now remember, you always have to go back and check if they make sense or not. Now if I plug 10 over here, 2 times 10 is 20. So that's a positive number. 10 minus 5 is a 5, so that's also a positive number. So this is a good answer. Now what about negative 5? Let's see if it makes sense. 2 times negative 5 is a negative 10, so I have a log of negative 10. Not possible. So that, what do we call this? An extraneous solution. So in a problem like that, we only have one solution where the x is equal to 10. Now in this video, we learned how to solve a logarithmic equation where you have a log on one side and a number on the other. Now please check the second video to see what you can do or how to solve logarithmic equations where you have a log on one side and a log on the other.